This is section 5.2, graphing in standard form. Our VICs and our vocab kind of go together. Remember last video we talked about our axis of symmetry and our vertex, and so those vocab terms still apply in this lesson also. So we're going to talk about standard form, which is y equals ax squared plus bx plus c. And to find the axis of symmetry in standard form, you want to do negative b over 2a. So you're taking the opposite of b and dividing it by 2 times a. Your vertex is hk still, but remember or know that x equals h is the axis of symmetry always. So x equals h is your axis of symmetry. So h in this vertex in standard form is found by doing negative b over 2a. And then the k value of your vertex is found by plugging that value for h, that negative b over 2a, back into your equation and solving for y, and that's your k value. So our example says graph y equals 2x squared minus 4x plus 1. So the first thing you want to do is find your axis of symmetry. So x equals negative b over 2a. The opposite of 4 is 4. 2 times 2 is 4. So 4 over 4 is 1. So x equals 1 is your axis of symmetry, and that's this dotted line right here through x equals 1. Then you want to find your vertex. So you're taking that 1, because that's the h value of your vertex, and plugging it back in. So you have 2 times 1 squared minus 4 times 1 plus 1, and you solve, and you get out negative 1. So your vertex is 1, negative 1, that's your hk point, and you're going to plot that right here. 1, negative 1. And then you want to find your y-intercept, just like when you graphed in vertex form. So you still do it the same way also. You plug in 0 for x. This time you have 2 x's, and you're going to plug in 0 for both of them. So you have 2 times 0 squared minus 4 times 0 plus 1. You should know that anything times 0 is 0, so these are going to cancel out, and you're going to end up with 1. So your y-intercept is 0, 1, and that's this point right here, 0, 1. Then you want to reflect that point, just like when we graphed in vertex form, over this x equals 1 line. And when you reflect it over, you get out the point 2, negative 1. Because
positive 1.
2, positive 1. Because this point is 1 away from your axis of symmetry, so 1 away gives you 2, 1. And then you draw the U shape through it. Example 2 is about writing equations. Example 2 says, given the vertex 2, negative 7 and point 45, write the equation in standard form. So, your equation in vertex form says y equals a times x minus h squared plus k. Again, hk is your vertex. So my vertex being 2, negative 7, 2, negative 7 is my hk. So I'm going to plug those in for those values. So I have y equals a times x minus 2 squared minus 7. And then I also have this point 45. That point 45 you can plug in for x, y, because that's a point on the coordinate plane, and you know that points on the coordinate plane are x, comma, y. So plugging that in, 5 in for y, a is what we're trying to solve for, then 4 in for x, minus 2 squared minus 7 from the vertex. And you're going to solve. So 4 minus 2 is 2, 2 squared is 4, and then you want to move the 7 over, so you're adding 7 to both sides, dividing by 4. You get a equals 3. So when you go to write your equation, you should start in vertex form. You want to start with y equals 3, because that's your a value that you solved for, 3 times x minus 2 from their vertex squared minus 7 from your vertex. And from here, the first thing you want to do is this x minus 2 squared means that you want to set it up as x minus 2 times x minus 2, and you want to FOIL. So you want to do the first terms, x times x is x squared. The outer terms, x times negative 2 is negative 2x. Inner terms, negative 2 times x is negative 2x. And when you add those together, that's where you get that negative 4 from. And negative 2 times negative 2 is 4. Then you want to distribute the 3. And then when you get to 3x squared minus 12x plus 12, you want to subtract 7. Or you want to combine like terms. So it's 12 minus 7 to get y equals 3x squared minus 12x plus 5.
And from here, you can graph it and start all over again.